Okay, so by the way, you can access all the recorded session from the ITEL. Okay, so today we will cover regression analysis. So this is considered one of the type of machine learning. As I mentioned before, we have supervised, unsupervised, reinforced learning. So when we talk about regression, we are actually talking about one of the methods that we use in supervised learning. So supervised machine learning can be categorized into regression and also classification. So how do we differentiate this? How do we know which one we apply in supervised machine learning? So if the dependent variable that we want to model are of type continuous variable, then we use regression. So whenever you have the data type of the attribute that you want to forecast, continuous variable or numerical values, and we call it regression. Otherwise, if the dependent variable is categorical value, like label, okay, so that is what we call classification task. So today we will look into this regression, where the dependent variable will be numerical value. So this is very useful when you want to forecast the stock market, or you want to forecast the number of COVID-19 cases every week or every month or every year. Okay? Or you want to look at the food per capita consumption every day, what people buy, how much they eat rice, how much they eat veggie, and so on. So from there we can know the demand and supply of food, of certain agro-food. Okay? So what is a regression analysis? We will look into this. What is the regression analysis? We also look at the simple and multiple linear regression. Simple here referring to only one variable that we want to um, include as the independent variable. But if you have more than two independent variable, let me draw here. So only your dependent variable that you want to forecast depends on your independent variable. So our DV depends on our independent variable. But this is simple linear regression because we have only one independent variable. But if we have a dependent variable depends on IV1 and also IV2 or more, then we call it multiple linear regression. So we will look into this. We will look at the logistic regression and also regression tree. They are considered one of the variant of regression, but this one is for categorical value. We call it logistic regression, and this is similar to what you have here, but they build a tree to indicate the partition of values, of numerical values that go into separate ways. So your value, for example, a here. So if a is greater than certain value, then it goes here. Otherwise, go here. Then it goes building the tree again. Let's take a look at the simple linear regression first. Okay, or multiple. So in this diagram, we have one dependent variable. Okay, this is how much salary you get. Okay, so this is called dependent variable because it depends on other factor, influenced by other factor. So the other factor ni we call it independent variable, would affect the value of your dependent variable. So in here we have the first one is the qualification, second one is the time you spend, and then the third one is age. So this is numerical value, this is numerical value, this is categorical value. Okay, but this is numerical value, continuous value. So when you want to do linear regression, your dependent variable is always numerical value. So contohnya macam ni, a simple linear regression, your dependent variable, your salary depends on only one independent variable. So it could be based on time or based on your qualification or based on time or based on your age. Or we could have all three of them. Qualification, amount of time you spend, and also your age. And we also have logistic regression. Different is that your dependent variable will be categorical value. So over here, this is all the value could be numerical and also categorical value, similar to this and this. Because we have this is categorical value, this is numerical, because this is the type of qualification you get. So maybe bachelor, master, or PhD, or just CGL only lah. If you look at the dependent variable here, this is a matrix. Matrix means numerical value. Okay, this is nominal or ordinal means they are labeled. It's the difference between simple, multiple, and logistic. So for simple, you only have one independent variable. For multiple linear regression, you have more than one independent variable. And for the logistic regression, your dependent variable is a categorical value. So ini nanti kita tengok next lecture lah. Now we look at these two. And based on the previous one I mentioned just now, this qualification is a categorical value. So contohnya gender, vehicle type, all these are considered as nominal or ordinal values. They are not numbers. They are label. Okay? So for this one, we will change them into dummy. So dummy means if they are female, so we say they are. Okay. I'll show you later on this one. How do we assume the dummy variable? Basically, we use the binary number to represent them. Okay. So for a simple linear regression, we look at a single variable, a single dependent variable, and also single independent variable. Okay. But for multiple, we have two independent variables. So our task is to model the data in such a way that we can draw a line that minimizes the differences between all the sample that we have and the straight line that we draw. And basically, the one line here can be represented as this formula. And the x is the age, and also the y is the estimated length of stay. So what you want to predict is this one, the length of stay. Okay, so the B and A here can be estimated. So you have this formula. The B is 0.14 and then A is 1.2. So basically the A is the intersection of the Y and X is 0. So if you have value for X is 33, okay, if the X is 33, then you can estimate the length of stay. Okay, and the A and B can be computed by looking at the coefficient, standard coefficient between x and y, and also the sy and sx are the uncorrected standard deviation of sample y and x. So for this one, the formula is quite complex, but the aim is when we draw a line, it will estimate the value for A and B based on this formula in such a way that it will reduce the differences between the actual and the predicted values of your y, the dependent variable. Okay, and at the same time also, like I mentioned just now, we want to reduce the differences between the dot, the actual dot, and also the dot on the line. So that will comprises all the error that we have. So we need to accumulate all the error, and these are the error that we have. Okay. So basically, what we want to do is we want to find a line that will minimize the sum of square error. Sum of square error is actually finding the differences between the actual and also the predicted one. Then you take the square. You take the square here because you want to eliminate the negative value in case if this is bigger than this. Then you take the summation. So that is what we call the sum of square error, or we call it residuals. So we adjust the slope so that we can minimize the residual value. And if we look at normally, if we look at this one, so if we have a straight line like this, we say that the x is highly correlated with the y. We cannot assume that if x and y are highly correlated, we cannot assume that they're linear. Okay, so if you look at this graph, they are linear. So we can say that x and y is highly correlated. But if you form the competition between correlation between x and y, and if they are close to 1, we cannot even say that they are what highly linear. Okay, let me show you this example. So if we look at sample can be run through by getting the data from the ANSCOM. Okay, we attach the data, then we look at the content of the ANSCOM. So what we want to do is we have 4 sets of data here. So we want to look at the characteristic of the data between x and y. So this is one pair. And then another pair is this, another pair is this, and then another pair of this. So let's check the correlation between x1 and x1 and y2, x2 and y2, and so on. So we can do that by typing this command. So this command will compute the correlation between x1 and y2. So if we do it for the other x2, x3, and x4, they are highly correlated and almost the same. Okay? But we cannot say that they are linear unless if we see the graph. Okay? So if we plot this graph, okay, we can plot x and y, x1 and y1, and then we get this. Okay. So for the plot one, they appear to be a true linear relationship. But for the plot 2 is curvilinear. And for plot 3, we have this outlier, so like that. And then for this one also, plot 4 is driven by one outlier also here. Okay, so your graph like that. So based on the correlation value, we cannot tell that two variables are highly have true linear relationship until we plot the graph. So if they are linear, we can say that they are highly correlated. But if they are highly correlated, we cannot say they are linear. We have to check the graph. Okay. Let's take a look at the first sample here. Okay. So the first sample here, we are trying to predict the water yield, kandungan water in inches of the river. And we want to look at the water level or the water yield of river based on the water content of the year snowfall. So basically we have this, let me check. Okay, so this is the yield. Okay, want to estimate this y based on x here. So this is the content of the water in the river. This is the content of the water in the snowfall. So this is your independent variable. This is your dependent variable. Okay, so you have all this value. So how do we perform the linear regression? Basically, we okay, this is just plotting. So on this plotting, we can draw a line here. Okay, so how do we perform the linear regression? We say, okay, we call the linear model, and this is your independent variable. This is your dependent variable. This is your independent variable. So we use the tilde here to show the relationship between the dependent and also independent variable. So that's it. So the result will be stored here. And then when you type the summary yield.fit, okay, you can say that the content is, the variable content is significant in terms of trying to predict or forecast the value for the dependent variable, because we have the 3 here. And we use this multiple R square for single or simple linear regression. So this one, the higher the value, the better they are. So we are looking at 1 here. Close to 1 is better. Okay? But for multiple linear regression, we look at here because you have multiple variable that could into the error. So we adjust the R square. Okay, so always remember, this one we this value for the R square for the simple one, and this is if you have multiple linear regression. And over here we can tell that from the 3 star here, they are very significant. Okay, so this is the p value lah. So this is the line that will be plotted that represent or can be used to characterize the data that we have. And that's it. Okay, so that is simple linear regression. So now we look into the multiple. So multiple linear regression is similar to simple one, but this one have 2 or more. But you only have one dependent variable also. Okay, so the formula for the multiple linear regression, you will have more than one x, so you will have x1, x2, xk, and so on. So the coefficient of this b1, b2, and bk and a will be estimated. Similarly, the simple linear regression in such a way that it will reduce the residual value, the sum of square value. So the formula that we have is normally looks like this because we have the error again. We have the error here again. So how do we estimate this beta 1, beta 2, and so on, and beta I? So what they did is, because we also have to estimate this one. So what they did is they introduce or they change this one to beta 0. And then they add another variable, the x0, just to make it standardized among all the variable here. The x0 here we put as 1 lah, because if x0 value is 1, still can go back to here. And then the b sub 0 is actually the alpha here. So from here we can construct a matrix. Okay, so a matrix that will have all this. So what we want to do is we want to estimate all the value for beta 0, beta 1, 2, 3. So this one is actually the alpha. Okay, so this is the residual that we have. Okay, so if we change them to a formula, so basically you have the y vector, also the matrix, and also the beta here, and also the error here. So in the R software, we could estimate value of this beta based on this formula, in which we just transpose the value of x times x, and then take the inverse of this product and times the x, the transpose of x, and times the y. So we can have the values in terms of vector here, because we want to estimate all this. Right? Because it goes back to here, you want to estimate this, this, beta 1, beta 2, and this one. So how do we do that one? So the formula is this one. So basically, they are doable in R. So basically, you provide the value for y and x, is the matrix. So we convert x into matrix, and then this is Columbine. So because we want to combine this with the matrix here, so that's why we have the column binding. So one and also all the x's. Then this is your x. So what we want to do is this is the inverse of the product of x transpose times x. This is the inverse, and then times the transpose of x, and times y. So this is the formula that we can use in order to estimate b, the beta vector. This is you done manually, but when we call in the linear model, they will estimate that one for you. This is just to show you that we can perform this one manually, and this is how they done in estimating the value for the beta. So the assumption that we require before we can perform the forecasting is that we have four. The first one is the relationship should be linear. Okay, and the second one is the error must be normally distributed, and also there'll be no multi-collinearity. That means two variables have highly correlation between two variables. Then the variance must be constant. Okay, let me go one by one just to describe you all these assumptions that made. Okay, first one is they must be linear. So how do we check that? Just plot the graph. So this is not linear. So this is linear. Okay, so the first assumption passed already. Second assumption is that the the error must be normally distributed. So we can use the total plot. Okay, so So this is the case that we have. Uh, so if we have more or less like this, then second assumption is it says that normal distribution of error that we have. And the third one is the we should not get this one in which the differences of variance occur along the values. So we must get this one, constant variance of the residual. So similar, we go here, this is the variance lah. Draw. So this is the variance. They are the same. And this one is not the same because the variance is too big, but here is none. Okay, so that's all the four here. One is linearity, normal distribution of error, and the last one is this one, multicollinearity. So in multicollinearity, two or more of the predictor correlate strongly with each other. So we do not want to have that one because if two variables are highly correlated to each other, then it is very difficult to interpret the coefficient of B1 and B2 because they are highly correlated. So we do not want to have X1 and X2 are highly correlated. So that are the basic four assumptions that we made when we form the linear regression. Okay, we go back to the dummy variable just now because we say that the independent variable should be only numerical value. But it could also be a categorical value. So how do we convert them? So we will convert them into 0 and 1. So for example, like this, if we have the variable for x1 is gender, female or male, so we will have 0 and 1 here. So that is our assumption here. Another example is that suppose that we want to estimate the fuel consumption based on the horsepower and vehicle type. So this is okay because they are numerical value. This is not okay because they are nominal value or technical value. So what happens is that we convert them into dummy variable. So we have 0 and 1, 0 and 1 to indicate that either they are positive or negative. Okay? So basically we will have this one similar to this, but this is for the gender. Okay, so if we have this the value, then we say that if they are sedan, this is 1, 0, 0. Okay, if they're sport car, so this is 0, 1, 0. The rest is nil. This is if we want to reduce one of them, simplify them from 3 variable with 2 characteristic to 2 variable with 2 characteristic each. So we can simplify them. Okay, any question? So this is very interesting because you can use this one to form any forecasting when you have numerical data. So let's take a look at this simple example here. In this example, we are trying to estimate the payment for the insurance based on the age, based on the sex, and based on BMI, based on number of children, based on whether you smoke or not smoking, and based on where you stay. So notice that this is numerical value. This is nominal or categorical value. This is numerical value, numerical value. This is categorical value, categorical value. But the one that we want to estimate is this one, the charges. So in this environment, we will read the data, and they are stored in a comma separated vector. And we say that the string as vector because we want to keep all the like for this one, sex, smokers, all in character. So we want to maintain them as label, so we put them as true. So meaning that all the character, string of character should be maintained as vector. So that's why we put true here. So when we put in the value, we have all vector here. Okay. Okay. So we could do some summary of the insurance. So this is the one that the dependent variable that we want to estimate. So they have the minimum here, the maximum, mean, and also median. And we could also look at the distribution of the charges. So we have a lot of people paying around 10,000 and not many paying more than 30,000. And we could also look at the correlation matrix by issuing this command. So we are looking at the correlation of the insurance for this particular column, age, BMI, children, and charges. And we can do correlation analysis for nominal value or categorical value. So that's why we only limit to numerical value. So the closer to 1 they are, the highly correlated they are. So in this case, we only have this highest one. So nearer to 1, saying that they are highly correlated. We could also use different technique. So we could use the pair plot them. For the plotting, remember just now plotting is the easiest way on how we can see whether the two variables are having true linear relationship or not. Okay, so we can only see this one, the age and charges. There's a more variant of this. We have this also. So in this one, they tell us the correlation value between the age and also the charges. And also they show the diagram here. And then they also, the dot here are referring to the median. And you see there is around here, the more they are stretched, the more they are highly correlated. So for example, like this, the correlation value is almost 0. So there is no stretch of the circle here. So this can be displayed by just typing the command that we have here. So we have 3 steps here. We install the package first, and then we build to show the diagram. Okay, so how do we perform multiple linear regression? We use the same thing here. So basically, we are calling linear model, dependent variable, and also use the tilde here, and also the dependent variable. So if you want to include all the independent variable, we just put dot. Let me show you. So this is how we call the function. We're looking at the linear model here, and this is your dependent variable. This is the tilde, and this is all the data that you have. This is when you malas to type. But if you want to specify what are the independent variables, so you have to type one by one. So you have to use the plus here. to show that you're going to model the charges based on the age and children and BMI and sex and region, and you get the data from this insurance data. So your model will be stored in here. So if you type your model, it will tell you this value. So this value saying that for every age increase, you need to pay another 256 ringgit and 90 cents. If you are male, you pay less, just minus this. If um, any additional children, you need to add 475. For any additional BMI, you need to add 339. If you are a smoker, you need to add this amount. And the moment you are paying more because you are staying at the northeast. But if you are staying in the northwest, you're paying less. If you're staying in southeast, you paying less, and so on. So this is how we interpret the result that we have. So these are the concluding remark that we get. And looking at this, like for this dummy one, so for the sex male, we put the sex male 1 and then sex male female 0. Okay, so if the sex is female, then the sex male is 0. This is what we have shown you here. This one, dummy. Yes, dummy. Hmm, this one. So uh, if you are female, then the value for female will be 1 and male is 0. If you are male, value for male will be 1 and 0, and so on. Okay. But if you look at the coefficient, looking at this, so BMI, children, and whether you are smoking or not, and also the age, has significant contribution to your linear modeling because the p-value is almost 0 here. So you can say that see the presence of the 3 star indicate a significant level of 0, which means that the feature is extremely unlikely to be unrelated to the dependent variable, meaning that they are not related, but they contribute more to the estimation of the value of the dependent variable. Okay, so normally we use the significant level of 0.05, which is this one. So 0.05, which is this one. But we have better. So this is significant level is 0.01. Then the significant level for the 2 star is 0.001. So the more star they have, the more significant they are. So for this one, we use this because we have multiple linear regression. Okay, so when people ask you how good is your model, we always refer to the R-square value that we have. This one. So at the end of the day, when you perform the linear modeling, you can always check the R-square because people look at the the quality of your model. But at the same time also, if you're looking for the significant trend, whether increase or decrease, you can also use another method, what we call man candle. The man candle method is used to verify whether there is a significant trend increasing or decreasing for the forecasting that you have made. So normally they use the R square or the man candle. Man candle is used to determine how significant is the trend that you have. Okay. Okay. Any question? Do you find this one is interesting?
Yes.
Okay.
This one undergraduate student, actually two, they are looking at this. Said, okay, how can I forecast the stock market based on people say in the news? So, or based on the headlines. Because every month we have headlines in financial or in politics. So, how do you relate the polarity of the sentiment of financial news with the stock market? So that is very interesting because I asked them something like this. Let me. Okay. So this one they try to estimate the stock market based on sentiment on financial news. So I said your Y will be what? So your Y will be the stock market. And your X will be the sentiment value of financial news. So basically you want to do this Y and the X, right? So the Y, you can get the stock market price for January to December, or you could make it weekly. Okay, but for the sentiment of financial news, how do you create this one? So I told my student, I said, okay, in January, you find all the financial news. So you only take the headline, and then you change them to polarity. Polarity referring to the sentiment value of the particular headline. So normally, if we have positive, means they are good news. If the value of the polarity is negative, that means they are negative sentiment. So as the student to okay, you go to news that time and then you collect all the headline of the financial and you convert them into polarity values. So now you have both of them, Y be numerical and X also to be numerical. So can you use the financial news to estimate this one? So how do you check that one? We will look at the R square. How do you measure the performance, or how do you measure whether the X is really can you really use X to be one of the independent variable for the stock market. Then I challenge them again. Okay, you have this is for the financial news. Okay. Then we also have politic news during that particular month or week. So I ask them to find all the political news, and then also we look at the uh, financial, political, and also all the entertainment news or the sports lah. So this is another challenge. Student could start with this only, and then you can add this one again. So I think last semester we have done the sentiment analysis, but we try again to go back to revise technique on how do we perform the sentiment analysis. But that's how we create the linear regression, just um, to estimate certain value based on several independent values. Okay. Let me show you the work that we done with the Ministry of Agriculture. A simple one. For example, okay. So this one is the penggunaan beras per isi rumah or per household. So we have all the data up to 2020. Um, 2022. Let me change that one because we have per isi rumah and also per capita. Okay. So this is penggunaan. Can you see this?
Are you sharing on PowerPoint?
Let me stop this. You see this? So this is the per capita consumption. Per capita consumption meaning that individual consumption of beras setiap tahun. Okay, so we have the data until 2020 actually. So 2020. So the bar here is referring to the GDP. Okay, GDP initial. So what we did, we focus the per capita consumption, berapa banyak we eat beras per year, based on our national GDP, which contribute to the purchasing power. Okay, so this is your independent variable. This is your dependent variable. So these are the forecasting that we get. So it means that in the next 5 years, people will eat less rice, maybe due to the more awareness about the health and so on. Okay, so the data that we have is from 2010 until 2021. So these are the history data that we have. So based on this, we forecast the next 5 years consumption of the beras on GDP. So we perform with the ayam etik also menurun. The babi is maintained. Lembu turun, kambing per kapita turun, telur ayam susu naik pula. So we provide this forecasting for the Ministry of Agro-Food so that they can strategize on how do they fulfill the requirement. Contohnya macam ni, sotong per capita will increase. So how do they develop a policy to increase the supply for sotong, supply for udang, supply for ikan tilapia, and so on. So sardin menurun, ikan kelim. So this is what we say for all this prior. We have all this trend that we have. So this is the trend. We use the main candle, in order to determine whether the trend is significant or not. So, for example, bayam. So based on the main candle technique, we say the trend is significant. So bayam, people want to the consumption is more every year. See, the next one is for kacang bendi. There is no significant trend. No significant trend. Although you can see that there's an increase, but the trend is not significant. Tidak berapa ketara lah the trend. So this is the report that we supply to the Minister of Agro-Food at the federal level. Okay, so that is for tonight punya class. So basically 1 hour. Okay, so you will have your first quiz setting. After this, be lecture 4 lah. So tomorrow we will continue with the logistic regression. So we will start at 8 o'clock before we take a break for the Hari Raya lah. Okay?
Tomorrow saya balik kampung, sir.
Hai? Balik kampung kan? Oh ya kan?
Bukan SD kah?
Thursday lah kan? Thursday boleh kah? Tapi takut. Tapi kalau Hari Raya, hari 5 tidak jadilah kan? Kan? So kita postpone pergi next week. Kalau bukan Hari Raya hari 5, jadi kita ada kelas tuh yang Thursday itulah. Tapi kalau Hari Raya hari 6, we will have the class lah. Kan? 1 hour saja.
Okay, Doctor.
Okay. Thank you for your time.
Thank you, Doctor.
Thank you.
Welcome.